हेलो दोस्तों। वेलकम टू द साइनिंग ब्रेन। आज हम चैप्टर नंबर 15 क्लास 7 एनसीईआरटी को पढ़ेंगे। चलिए, चैप्टर का नाम है लाइट्स। शुरू करते हैं। यू माइट हैव सीन अ बीम ऑफ सनलाइट व्हेन इट enters a room through a narrow opening or a hole. You may have also seen a beam of lights from the headlamp of scooters, cars, and engines of trains. Figure 15.1a. Similarly, a beam of light can be seen from a torch. Here, figure 15.1a, beam of light, rail engine, and B, lighthouse. Some of you may have seen a beam of searchlight from a lighthouse or from an airport tower. Figure 15.1b. What do this experience suggest? Here, figure 15.2, looking at a candle through a street and a bent pipe. 15.1, light travel along a straight line. Bozo recalled an activity he performed in class 6. In that activity, he looked at a lighted candle first through a straight pipe and then through a bent pipe. Figure 15.2. Why was Bozo not able to see the candle flame through a bent pipe? This activity shows that light travels along straight lines. How can we change the path of light? Do you know what happens when light falls on a polished or a shiny surface? 15.2, reflection of light. One way to change the direction of light is to let it fall on a shiny surface. For example, a shiny stainless steel plate or a shining steel spoon can change the direction of light. The surface of water can also act like a mirror and change the path of the light. Have you ever seen the reflection of trees or buildings in water? Figure 15.3. Figure 15.3, reflection of object in water. Any polished or shiny surface can act as a mirror. What happens when light falls on a mirror? You have learned in class 6 that the mirror changes the direction of light that falls on it. This changes of direction by a mirror is called the reflection of light. Can you recall the activity in which you got the light of a torch reflected from a mirror? Let us perform a similar activity. Activity 15.1. Take a torch, cover its glass with a chart paper which has three narrow slits as shown in figure 15.5. Spread a sheet of chart paper on a smooth wooden board. Fix a plain mirror strip vertically on the chart paper figure 15.5. Now direct the beam of light on the mirror from the torch with slits. Place on torch in such a way that its light is seen along the chart paper on the board. Now adjust the position so that the light from the torch strikes the plane mirror at an angle 15.5. Figure 15.5, reflection of light from a mirror. Does the mirror change the direction of the light that falls on it? Now move the torch slightly to either side. Do you find any changes in the direction of reflected light? Here one information is given. Paheli remembered the story of the lion and the rabbit from the Panchtantra, in which the rabbit fooled the lion by showing him his reflection in water. Figure 15.4, reflection of the lion in water. Look into the mirror along the direction of the reflected light. Do you see the slit in the mirrors? This is the image of the slits. This activity shows how light gets reflected from a plane mirror. Let us play around with the images formed in mirror and know a little more about them. Figure 15.2. Caution. Handle the activity 15.2. Handle the lighted candle with care. It is better if this activity is performed in the presence of a teacher or an elder person. Place a lighted candle in front of a plane mirror. Try to see the flame of the candle in the mirror. It appears as if a similar candle is placed behind the mirror. The candle which appears behind the mirror is the image of the candle formed by the mirror. The candle itself is the object. Now move the candle to different position in front of the mirror. Observe the image in each case. Figure 15.6. Image of a candle in a plane mirror. Bojo noted in his notebook, "Is it not surprising that my image is of the same size as me whether the image is small or large? Was the image upright in each case? Did the flame appears on the top of the candle as in the objects? Such an image is called erect. An image formed by a plane mirror is erect and the same size as the object. Now place a vertical screen behind the mirror. Try to obtain the image of the candle on this screen. Can you get the image on the screen? Now place the screen in the front of the mirror. Can you get the image on the screen now? You will find that the image of the candle cannot be obtained on the screen in either case. What about the distance of the image from mirror? Let us perform another activity. Activity 15.3. Take a chessboard. If a chessboard is not available, draw on a chart paper 64 8 into 8 square of equal size. Draw a thick line in the middle of the paper. Fix a plane mirror vertically on this line. Place any small object such as a pencil sharpener at the boundary of the third square counting from the mirror. Figure 15.7. Note the position of the image. Now shift the object to the boundary of the fourth square. Again, note the position of the image. Did you find any relation between the distance of the image from the mirror and that of the object in front of it? Figure 15.7. Locating image in a plane mirror. Paheli made a note in her notebook. In a plane mirror, the image is formed behind the mirror. It is erect, of the same size, and is the same distance from the mirror as the object is in the front of it. You will find that the image is at the same distance behind the mirror as the object is in front of it. Now verify this by placing the object anywhere on the chart paper. 15.3. Right or left. When you see your image in a plane mirror, is it exactly like you? Have you even noticed that there is one interesting difference between you and your image in a mirror? Let us find out. Activity 15.4. Stand in front of a plane mirror and look at your image. Raise your left hand. Which hand does your image raise? Figure 15.8. Now touch your right ear. Which ear does your hand touches in your image? Observe carefully. You will find that in the image the right appears left and the left appears right. Note that only sides are interchanged. The image does not appear upside down. Now write down your name on a piece of paper and hold it in front of a mirror. Figure 15.8. Left hand appears on the right side in the image. How does it appear in the mirror? Bojo saw an ambulance on the road. He was surprised to see that the word ambulance in the front was written in a strange manner. Can you now understand why the word ambulance is written in figure 15.9? Here, figure 15.9, an ambulance. When the driver of a vehicle ahead of an ambulance look in her or his rear view mirror, she or he can read ambulance written on it and give way to it. It is the duty of every one of us to allow an ambulance to pass without blocking its way. You might have observed that in the side mirror of a scooter or a car, the image of all objects appear smaller than the object themselves. Have you even wondered why is it so? 15.4, playing with a spherical mirror. Paheli and Bozo were waiting for their dinner. Bozo lifted a stainless steel plate and saw his image in it. Oh, this plate acts as a plane mirror. My image is erect and is of the same size. Paheli saw her image using the back of the steel spoon. Bozo, look here. I can also see my erect image through it, though it is smaller in size. This spoon also acts as a mirror of some kind, said Paheli. You can also use a spoon or any curved shining surface to see your image. Activity 15.5. Take a stainless steel spoon, bring the outer side of the spoon near your face and look into it. Do you see your image in it? Figure 15.10. Is this image different from what you see in a plane mirror? Is this image erect? Is the size of the image the same, smaller or larger? Figure 15.10, image from the outer side of a person. Now look at your image using the inner side of the spoon. This time you may find that your image is erect and larger in size. If you increase the distance of the spoon from your face, you may see your image inverted. You can also compare the image of your pen and pencil instead of your face. Figure 15.11, image from a inner side of a spoon. The curved shining surface of a spoon acts as a mirror. The most common example of a curved mirror is a spherical mirror. If the reflecting surface of a spherical mirror is concave, it is called concave mirror. If the reflecting surface is convex, then it is called convex mirror. Figure 15.12. A concave mirror and B convex mirror. Why are concave and convex mirror called spherical mirrors? Take a rubber band and cut a portion of it with a knife or a hacksaw blade. 15.13a. Be careful. Ask an elder to help you in cutting the ball. The inner surface of the cut ball is called concave and the outer surface is called convex. Figure 15.13b. Here figure 15.13, it shows a spherical mirror is a part of a sphere. The inner surface of a spoon acts like a concave mirror while its outer surface acts like a convex mirror. We know that the image of an object formed by a plane mirror cannot be obtained on a screen. Let us investigate if it is also true for the image formed by a concave mirror. Activity 15.6 Caution. You will conduct activity 15.6 in the sunlight. Be careful. Never look directly towards the sun or its image as it may damage your eyes. You may look at the image of the sun when it is thrown on a screen or a wall. Figure 15.14 A concave mirror form a real image of the sun. Take a concave mirror, hold it facing the sun. Try to get the light reflected by the mirror on a sheet of paper. Adjust the distance of the paper until you get an sharp light spot on it. Figure 15.14 Hold the mirror and the sheet of the paper steady for a few minutes. Thus the paper start burning. This bright spot is in fact the image of the sun. Notice that this image is formed on a screen. An image formed on a screen is called the real image. Recollect that in activity 15.2, the image found by a plane mirror could not be obtained on a screen. Such an image is called virtual image. Now, let us try to obtain on the screen the image of the candle flame formed by a concave mirror. Activity 15.7 Fix a concave mirror on a stand. Any arrangement to keep the mirror steady would do, and place it on a table. Figure 15.15 Paste a piece of white paper on a cardboard sheet, say about 15 cm into 10 cm. This will act as a screen. Keep a lighted candle on the table at a distance of about 50 cm from the mirror. Here figure 15.15 Real image found by a concave mirror. Try to obtain the image of the flame on the screen. For this, move the screen till a sharp image of the flame is obtained. Make sure that the screen does not obstruct the light from the candle falling on the mirror. Is this image real or virtual? Is it of the same size as the flame? Now move the candle towards the mirror and place it and at different distance from it. In each case, try to obtain the image on the screen. Record your observation in table 15.1. Is it possible to obtain the image on the screen when the candle is too close to the mirror? Figure 15.16. We see that the image found by a concave mirror can be a smaller or a larger in size than that the object. The image may also be real or virtual. Concave mirrors are used for many purposes. You might have seen doctor using concave mirror for examining eyes, ears, nose and throat. Concave mirrors are also used by dentists to see an enlarged image of the teeth. Figure 15.17. The reflectors of torches, headlights of cars and scooters are concave in shape. Figure 15.18. Figure 15.17 A dentist examining a patient. Bozo observed his image in the shiny surface of the bell on his new bicycle. He found that his image was erect and smaller in size. He wondered. Figure 15.18 Reflector of a torch. And figure 15.19 Image found by a convex mirror. He wondered if the bell is also a kind of a spherical mirror. Can you recognize the type of the mirror? Note that the reflecting surface of the bell is convex. Activity 15.8 Repeat activity 15.7 with a convex mirror in place of the concave mirror. Figure 15.19. Record your observation in a table similar to the table 15.1. Could you get a real image at any distance of the object from the convex? Table 15.1 Image found by a concave mirror for an object placed at different distance from it. Did you get an image larger in size than the object? Can you now recognize the mirrors used as side mirror is in automobiles? These are convex mirrors. Convex mirrors can form image of object spread over a large area. So this helps the drivers to see the traffic behind them. Figure 15.20 Convex mirror as side view mirror. 15.5 Image found by lenses. You might have seen a magnifying glass. It is used to read very small print. Figure 15.21 You might have also used it to observe the body parts of a cockroach or an earthworm. The magnifying glass is actually a type of a lens. Lenses are widely used in spectacles, telescope and microscope. Try to add a few more uses of lenses to this list. Get some lenses, touch and feel them. Can you find some difference just by touching? Those lenses which feels thicker in the middle at the edges are convex lens. Figure 15.22a. Those which feels thinner in the middle than at the edge are concave lens. Figure 15.22b. Note that the lenses are transparent and light can pass through them. Here figure 15.22a convex lens and b concave lens. Let us play with lenses. Caution. It is dangerous to look through a lens at the sun or a bright light. You should also be careful not to focus sunlight with a convex lens on any part of your body. Activity 15.9 Take a convex lens or magnifying glass, put it in the path of sun rays, place a sheet of paper on as shown. Figure 15.23 Adjust the distance between the lens and the paper till you get a bright spot on the paper. Hold the lens and the paper in the position for a few minutes. Thus the paper begin to burn. Now replace the convex lens with a concave lens. Do you see a bright spots on the paper this time? Why are you not getting a bright spot this time? We have seen in this case of the mirrors that some different positions of the object, the nature and size of the image change. Is it true for lenses also? Let us find out. Activity 15.10 Take a convex lens and fix it on a stand as you did with the concave mirror. Place it on a table. Place a lighted candle at a distance of about 50 cm from the lens. Figure 15.25a. Try to obtain the image of the candle on a paper screen placed on the other side of the lens. You may have to move the screen towards or away from the lens to get a sharp image of the flame. What kind of image did you get? Is it real or virtual? Now vary the distance of the candle from the lens. Try to obtain the image of the candle flame every time on the paper screen by moving it. Record your observation as you did in activity 15.7 for the concave mirror. It means that we can see the image found by a lens from the side opposite to that of the object. Figure 15.25 Image by convex lens for object placed at different distance from it. Figure 15.26 virtual image formed by the convex lens. Figure 15.27 image formed by a concave lens. Did you get in any position of the object an image which was erect and magnified? Figure 15.26. Could the image be obtained on a screen? Is the image real or virtual? This is how a convex lens is used as a magnifying glass. In a similar fashion, study the image formed by a concave lens. You will find that the image formed by a concave lens is always virtual, erect, and smaller in size than the object. It means you will find that the image formed by a concave lens is always virtual, erect, and smaller in size than the object. Figure 15.27. 15.6 Sunlight, white or colored. Have you ever seen a rainbow in the sky? You might have noticed that it appears usually after the rain when the sun is low in the sky. The rainbow is seen as a large arc in the sky with many colors. Figure 15.28. How many colors are present in a rainbow? When observed carefully, there are 7 colors in a rainbow. Through it may not be easy to distinguish all of them. These are red, orange, yellow, green, blue, indigo, and violet. Thus, does this mean that the white light consists of 7 colors? Figure 15.30. A prism split a beam of sunlight into 7 colors. You might have seen that when you blow soap bubbles, then they appear colorful. Similarly, when light is reflected from a surface of a compact disk, you see many colors. Figure 15.29. On the basis of these experiences, could you say that the sunlight is a mixture of different colors? Let us investigate. Activity 15.11. Take a glass prism. Allow a narrow beam of sunlight through a small hole in the window of a dark room to fall on one face of the prism. Let the light coming out of the other surface of the prism a white sheet fall on a white sheet of paper or on a white wall. What do you observe? Do you see colors similar to those in a rainbow? Figure 15.30. What this shows that the sunlight consists of 7 colors. The sunlight is said to be white light. This means that the white light consists of 7 colors. Try to identify these colors and write their name in your notebook. Can you mix these colors to get white light? Let us try. Activity 15.2. Take a circular board disc of about 10 cm diameter. Divide the disc into 7 segments. Paint the 7 rainbow color on this segment as shown in figure 15.31a. You can also paste colored paper on this segment. Make a small hole at the center of the disc. Fix the disc loosely on the tip of a refill of a ball pen. Ensure that the disc rotates freely. Figure 15.31a. A disc with 7 colors. And figure B. It appears white on rotating. Rotate the disc in the daylight. When the disc is rotated fast, the colors get mixed together and the disk appear to be whitish. Such a disk is popularly known as Newton's disk. Paheli has a brilliant idea. She has prepared a small top with a small circular disc with 7 rainbow colors painted on it. Figure 15.32. When the top rotates, it appears nearly white. A top with 7 colors. Keywords: concave lens, magnified image, rear view mirror, concave mirror, magnifying glass, side mirror, convex lens, prism, spherical mirror, convex mirror, rainbow, virtual image, erect image, real image. So फ्रेंड, दिस इज़ द एंड ऑफ दिस चैप्टर. अगले क्लास में हम नेक्स्ट चैप्टर के बारे में पढ़ेंगे. तब तक धन्यवाद.